Hello guys, welcome to my channel. So today we are going to start a topic called impulse. So impulse actually it is coming under and collision and center of mass, but we are taking the topic now. So impulse. So what do you know about impulse? Impulse is simply change in momentum. Okay, so impulse we usually denote by the sign I, or here we can take J. Okay, this is not torque, this is J. So impulse. Impulse means when a very small force, when it's very large force acts for a very small interval of time, we call it as an impulse. See, let's see an example. When a ball hits a ball, when a ball is hitting a ball, at that instant of time, it is hitting the ball only for a small instant of time, but the force with which the ball is falling is very large. So that's a very important example of an impulsive force, when a large force acting for a very small interval of time, because that interval of time is when the ball is hitting the wall. So that's not impulse. So impulse is simply a large force acting on a very small interval of time. So we denote J as F dt. It is a very small time interval, therefore it is dt, a larger force. So usually we are taking the sum of all the large forces and the small intervals of time. So we are integrating, and so it's integral. So impulse is defined as integral of F dt, and also it is equal to change in momentum. See, change in momentum. Okay, here we can prove that we know according to Newton's second law, force is equal to dp by dt. Change in momentum, rate of change of what the second law states. Second law states that the force acting on a body is equal to the rate of change of its momentum. So if we dp by dt is equal to f. Now we can write f dt as dp. So here f dt, so integral dp p initial to p final, that is equal to p final minus p initial. We are putting the integral, differentiating, put the integral, we get change in momentum. Therefore we can define impulse as change in momentum. So whenever we are asked impulse, we cannot calculate the interval, small interval of time or the force, because this small interval of time is very small. We cannot actually directly calculate it. Also we can calculate the force maybe, but not that small time interval. Therefore we are defining impulse as change in momentum. Now we can calculate impulse because it's simply change in momentum. We only have to find change in momentum. Therefore this is impulse. Now if we are given a force time graph, if we are given a force time graph, suppose like this, then impulse, now we can calculate impulse. Impulse is area under the graph. Impulse is area under the graph. Impulse is area under FT graph. Area under force time graph. Okay. Now there are different types of impulsive forces. Okay. Now we have to remember that impulse is a vector quantity. Of course it's a vector quantity because it has the direction of force or direction of change in momentum. Wherever the momentum change direction is, we are getting the sign, that same direction this impulsive force will go. Impulsive force is a relative term. We cannot actually define particular force is impulsive and particular force is non-impulsive. No, actually it's a relative term. But we can say, for example, gravitational force. See, gravitational force is it's acting downwards. It's pulling every object towards itself. So actually it is a non-impulsive force because it is not acting only for a small time. See, gravitational force is not acting for a small time. It is always acting there. So for a large interval of time. Therefore we cannot define it as an impulsive force. Also spring force. See, this spring force is there, no? In the spring force is also not gravitational. It's also not impulsive force, because spring force is acting. It is always present there. whenever the block is there, or it is always present there. So we cannot actually define it as impulsive force. Now, in our motion, in our laws of motion, we actually had to encounter 5 types of forces. First one is normal force. Then there was frictional force. Then there was tension. In a string there was tension, right? So tension, friction, normals, and then our spring force and our gravitational force. So we already defined gravitational force and spring force as non-impulsive forces because they are always present there. They are always present no matter what the conditions are. Now we have to check what this normal force, tension in a string, and frictional force. Okay, coming back, let's see. Now we are going to check normal reaction, frictional force, and our tension. These forces, we cannot define these forces as impulsive or non-impulsive directly. It depends on the situation. Depends on the situation whether it has become impulsive or non-impulsive. So let's check first the situation. There are 2 blocks, M1 and M2. Let's take M1 and M2 as 2 blocks. Now they have collided at a point here. They are coming too close to each other. They are colliding at here. They collide here. Then they are moving away. So when they are colliding here, a normal reaction is acting. See, whenever 2 bodies are in contact, a normal force happens. So when these bodies are colliding here, that is they are meeting here, a normal force is formed. A normal force of reaction. This normal force is formed here, and this normal force is opposite in direction but same in magnitude. Okay. See, this M1 has a normal reaction N1. This M2 has a normal reaction N2. Now, I'm asking you, which are the impulsive forces and which are the non-impulsive forces? See, we have already that impulsive forces are those forces that is acting for a small duration of time. Here, when these bodies are colliding, they collide, and at that point, what will happen? That point, this normal reaction, this force is generated. So when a force is generated, when an impulse is generated, when a force act for a small interval of time. So this normal reaction is acting for a small interval of time. Therefore, we can say that N is an impulsive force. N is an impulsive force. Okay, impulsive force. But check N1 and N2. Are they impulsive? No, they are always present there. See, they are always pulling the body to the downwards direction. They are not providing any impulsive force. See, even if this body is moving here, even if they are colliding, and after that they are moving back, but this N1 and N2 are not doing any work, or they are not doing anything. They are not providing any force, additional force. They are not providing any additional force. So N1 and N2 are non-impulsive. Okay, so next, so this is the first case. Then we will check the next case. A sphere is kept, and on top of it another sphere is kept, dropped, another sphere is dropped, and this sphere is laying in the ground. Now we will mark the forces. Here this sphere has a normal force N1. Here, due to contact, a normal reaction will be formed, N and N. Okay, that's all. This does not have any additional force. See, now say N and N. This N and N1. We have to determine which are the impulsive forces, which are the non-impulsive forces. We can say for sure now that N is a impulsive force because it's acting for a short duration when the small ball is falling on the large ball. So N is obviously impulsive. impulsive. Now check N1. N1 is pulling the body downwards, but this ball is also pulling the large ball downwards. So some additional force is applied. When additional force is applied, it obviously becomes impulsive, because when the additional force is applied, now a force is applied for a small duration of time. See, this body was there for a small duration of time. Earlier, when this body was not there, N1 can be termed as non-impulsive force, nothing is happening. But when the body is kept on top of it for a small duration of time, some force is acting there. Therefore, N1 is also impulsive. N1 is also impulsive. In this case, N1 is also impulsive. Next, we will check other case. Another case, case 3. That's of two balls, two spheres. They are in the ground. First we are having N1. This has N2. They are acting downwards, normal reaction. Normal reaction. Actually, this normal reaction is supposed to go up, right? It's okay, we can mark it as any direction. Actually, it's supposed to go up. But it does not change our conditions, okay? So here, these bodies are in contact. So there will be a normal reaction like this. There is a huge sphere. Then there is a small sphere. This sphere has N1 normal reaction, N2 normal reaction. Here there is a normal reaction N. See, they are perpendicular to each other. Okay. See, which are the forces that are impulsive and which are non-impulsive? We can say for sure that N is impulsive. What about N1 and N2? See, we can actually resolve this N and this N. So first we are taking the idea of small body so that we can find N2. N has this small n has a component downwards. So when this has a component downwards, it means that it's providing additional force. When it's providing additional force, we can say N2 is also impulsive. N2 is also impulsive, right? Now see N1. This N has a component upwards. Upwards means in same directions upwards. So it's not providing any additional force. It's not required because already there is a force upwards. Now again there is a force upwards. It's of no use. There is no impulse. So N1 is non-impulsive. Okay. N1 is non-impulsive. Now we are going to see the case of tension. Impulsive tension. So we checked the normal force. Now we are going to check tension. Tension force. Tension is always acting in a string. So let's take a string. With its one end is fixed. So consider the string. The string is kept like this. Now the string is taut. Tension is acting. Okay, tension is acting upwards, it's acting downwards. Consider at this point, we are considering this point, okay. We have to check whether this tension is impulsive or non-impulsive. Here, tension is acting upwards and it is acting at this particular. First, at this time, there was no tension. This body was kept upwards. It was held up by some other external force. And at this point, there was no tension. There is no impulsive force. So then they are released. When they are released, this body comes to rest here. Tension is developed, and this tension acts for that particular time at this point only. So this tension is impulsive. This tension is actually impulsive. Okay, next we are considering when a joined system. When both ends are fixed. See. When both ends of a ball are fixed by a string and a bullet is fired like this. A bullet is fired. This has a tension T. See, when a bullet is fired, this bullet actually goes to this ball. It gets embedded in the ball B. Gets embedded in the ball B, and when it gets embedded in the ball B moves in that direction, pulling the ball A towards that direction, and as a result tension is developed, and this tension acts on only when the bullet is hitting the ball P. Therefore this tension is impulsive. So this tension questions are very important. Yeah. Okay, we will do a problem. So here's our question. A string is kept here, it is to be released, and this distance is 1 meter. So we have to find the impulse immediately after the string becomes taut. So let's draw a picture when the string has become taut. When the string has become taut, the string has travelled an additional distance of 1 meter. So this distance becomes equal to 2 meter. Right. See, now we have to find impulse. Impulse is what? Impulse is integral T delta V by T delta T. T is the tension, and here tension is the impulsive force. We have learned that here in this case, tension is the impulsive force. Therefore, we write T delta V, and actually we cannot calculate like this, so we are taking as delta P. So initially, what was the momentum? Initially, the ball did not have any velocity. It was kept at rest, and so it's a 0. This delta P is equal to P final minus P initial, right? P final minus P initial. So final. So we have to check. Initially, the body was kept at rest, but when immediately after, so we are asked to find the impulse immediately after the string becomes taut. So after the string becomes taut, we have to find the impulse. So this is our final case, this is our initial case. Finally, the string has become taut, that means its velocity at that point is 0. Therefore, this one becomes 0 minus m initial velocity. V final is 0. So what is our initial velocity? Go back to our straight line motion, and we will find that when a body is falling through a distance 1 meter, its velocity is root 2gh. Right? Yeah. So our initial velocity is same, 0 minus m v initial, that is root of 2 into 10 into 2, that is root 40. Now, if it's given, suppose it's given mass is 1 kg, then we will get our impulse as minus root 40. Just remember, with this minus sign indicates that, this direction, this impulse, we already said that impulse is the direction, impulse has the direction of this our force, and it has the direction of change in momentum. So impulse has the direction of force, and see, direction of force is upwards. We have taken downwards as the positive direction, right? So since we have taken downwards, this is to indicate that the impulse is acting upwards. It's a negative sign, means simply the direction, it does not indicate magnitude. Okay. Well, this is a small topic of impulse. Hope you guys like the session. So thank you and welcome, and thank you very much for watching my videos. See you.